Hello everyone, my name is Joseph Thamir, and you're watching my Proof of Tech tutorial video on creating a custom character and streaming in levels in Unreal. Before I start, please understand that while I did create the system from scratch, I had spent a bit of time before starting examining Unreal's third-person templates character for its movement system, its 2D character for how they dealt with flipbooks, and Unreal's official documentation for referencing regarding struts, data tables, and level streaming. The programs I'll be using in this video include Photoshop, Krita, and Unreal Engine version 20.2. What you see now on the screen is the end result of this video, a custom character moving in a 3D space that triggers a level to stream in. The main character will roam around an overworld map, with each step causing the system to run an RNG check. If one of these checks come back positive, a battle will be triggered and the battle board level will be streamed in. To do this, I create sprites to use in the overworld character controller. I need to figure out a customized movement system for the overworld character controller. I need to create an RNG trigger that loads and unloads the system. And lastly, I need to create a system to load and unload the correct levels. In this video, the only asset needed to be made outside of Unreal are the sprites. For this, I started in Photoshop. I created 5 sprites of the character Logan, one facing towards us, away from us, straight to the left and away, and left and towards us. I then put them all on the same sheet, making carefully sure to keep them equally spaced apart. Because Logan's luckily symmetrical, to get the right facing sprites, I simply had to mirror the left facing ones and put them into position. I saved this document as a PNG and moved it into Krita to create the rest of the sprites. Side note, I could have done all this in Photoshop itself, but I'm more comfortable manipulating sprites in Krita than Photoshop, so I use Krita. Once all the sprites were made, I cropped them all into equally sized PNGs and named them Logan_C, followed by either a D or a U for down facing or up facing, and L or R for left facing or right facing, followed by another underscore and the number of the sprite. While this sounds like a lot to remember, I did have Krita doing most of the work for me, so the process didn't take more than a minute. In the Unreal Launcher, I created a new file without the starter contents, and named it Glory. Once opened, I created a few folders under the content folder, but the important ones for this video were the ones named Assets, Maps, and Blueprints. In the Assets folder, I created 2 more folders named 2D and 3D. In the 2D folder, I created 3 more folders: Flipbooks, Imported Images, and Sprites. And finally, in the Imported Images folder, I imported all the images I made. With all of them selected, I right-clicked and created sprites out of the images, moving them into the sprites folder soon after. In the sprites folder, group by group, I selected the sprites of the same direction and right-clicked to create flipbook animations out of them. Because of the naming convention I used, the flipbooks were created with the proper names. I then moved all these flipbooks into the flipbook folder. In the flipbook folder, one by one, I went into the flipbook editor and changed the frame rate to 5 frames per second. Once all of them were changed, I duplicated all the flipbooks and added an underscore idle to the duplicate's name. Opening up all the duplicates, I removed all but the first sprite of each. In the Blueprints folder, I created 5 new folders named Actors, data tables, enums and struts, game managers, and system. In the enums and struts folder, I created two enumerations, game mode and size class. In game mode, I gave it 4 displays: menu, battle board, battle combat, and overworld. In size class, I also gave it 4 displays: normal, tiny, champion, and titan. While this enum will have little to do with the rest of this video, it will be needed for later functionality in other parts of the game, so I decided to create it early. In the same folder, I then created a strut named Character Info Strut. Character Info Strut was a bit more complicated. However, for this video, there were 3 things that this strut needed: a string name, character name, a float named movement speed, and an array of flipbooks named overworld animations. Back in the data table folder, I right-clicked and created a new data table based off the character info strut and named it TT underscore all characters in game. In here, I created a single entry. I changed the character's name to Logan and movement speed to 100. In the array, I gave it 9 elements. The order was as following: CD idle, CR, CL, CU, CD, CUR, CDR, CUL, and CDL. After that, everything was compiled, saved, and closed. In the Game Managers folder, a blueprint actor was created and named System Manager. In it, it contained 2 variables. The first was named GameState. This was set to the enum GameState, with the default value being set to Overworld. The second was an integer named eRate, with a default value of 50. While later this blueprint will control the ins and outs of the board game, right now its sole purpose is to house these 2 variables. In the System folder, 2 game modes were created. The first was named System underscore Overworld Map Game Mode, and the second was named System underscore Game Mode Test. Next, a character was created and named System underscore Map Pawn. It was given 5 floats named MoveRY, MoveRX, MoveRY Stored, MoveRX Stored, and character MoveVar, with character MoveVar's default value set to 100. Next, the character was given a name variable named Active Lord that was set to Logan, and an integer named RNGC Counter that was set to 0. For debugging purposes, all these were set to public. A flipbook component was then added to the actor, and the default was set to CD underscore idle. It was scaled to fit and tilted 20 degrees upwards. Next, the camera was added and moved a fair distance away from the flipbook. It was tilted 20 degrees downwards so that it was facing the flipbook head-on. In the event graph, I started from the begin play and pulled out into an enable input node. From the player controller, I simply used the get player controller. From this node, I also enabled mouse over events, enabled touch events, and enabled touch over events. I then added the get all actors of class node and searched for the system manager class. I ran this through a for each loop and promoted the element into a reference. Since there will be only one of these actors in the level at any time, I found this to be a very simple way to create a reference between the 2. I then created 2 new custom events in the event graph. The first was named mLoop, and the second was named Change Flipbook. To end the event begin play line, I then told it to go into the mLoop. From the mLoop, I created a new macro and named it Check Movement Input Keys. I gave it an execution input and an then output, as well as 2 float outputs that I named MoveX and MoveY. The macro led into two add movement input nodes, with the first add movement input node having a direction of 1, 0, 0 and having move x value for scale value, and the second having a world direction vector of 0, 1, 0 and move y value as its scale value. The second node then led into a delay. I right-clicked in front of the delay and added a float divided by a float node, and fed this into the delay. Setting it to 1 divided by 120, I found this to be a cleaner way to delay it rather than entering a long string of numbers. After the delay, the line was led into a branch. The false output of this branch will go back to the beginning of the loop. The move var x and the move var y were checked to see if they were both not equal to 0. These booleans were led into an OR boolean node that led back to the branch. The true output of this branch was led into a set RNG C counter node. 1 was added to the RNG C counter. Then the RNG C counter would be checked to see if it was greater or equal to 50. If this came back as false, then it would go back to the beginning of the loop. If the check came back as true, the RNGC counter would be set to 0 and the line would go into a new macro named encounterRoll. This macro will only have an output of a boolean that will go straight into another check. If this check came back false, it would go back to the beginning of the loop again. If this check came back true, the line would lead into a load stream level node and then into an unload stream level node. The load stream level node then had its name variable promoted to a public variable named zone area name. The make visible after boolean was then set to true. The unload stream level node's name was also promoted to a public variable. It was named current level. Back in the check movement input key macro, the getPlayer controller was placed down and fed into two isInputKeyDown nodes. Just as a side note, this process could be done in the project settings, but I find this way to be much easier for myself to create an optional button mapping menu for the player if one wished. The first key was set to the A key on the keyboard, while the second key was set to the left arrow key on the keyboard. These ran into an OR boolean node, which in turn ran into a branch. I then copied and pasted everything from the getPlayer controller to the branch. The false branch of the first would feed into the copied branch. I then changed the key inputs for the copied input down nodes to the D and right arrow keys, respectively. I then took the first branch's true output and led it into another branch, with another getPlayer controller node and another isInputKeyDown node fed into them. The key set here was the left shift key on the keyboard. Both the true and false outputs this branch led into setMoveVarY nodes. The value of the true was set to character move var multiplied by -2, while the false was set to character move var multiplied by -1. This entire chunk was then copied and pasted, with the only changes being the removal of all the negatives. The second true output from the branch below was led into here. Finally, the last false output was led into a setMoveVarY that was set to 0. Every path was led into a single reroute node. Everything in the macro was then copied and pasted. The reroute node led into the paths section. The keys were set in the following order: S, down key, W, up key, and finally all the copied setMoveVarY nodes were replaced with the setMoveVarX, and every path was led into a new branch. The MoveVarY was checked to see if it wasn't equal with the MoveVarY stored, and the MoveVarX was checked to see if it wasn't equal to the MoveVarX stored. These checks were led into an OR boolean, and then into the branch. The false output was led into the output node of the macro, while the true output was led into a set move var y stored and a set move var x stored. Move var y was set from the first, and move var x was set from the second. This then led into a change flipbook call before also going into the output node. Finally, move var x and move var y were set to the two output floats of the macro. Everything was then compiled and saved. After that, I went back into the event graph and started work on the change flipbook events. From the change flipbook event, I added a get data table row and set the data table to the dt_all characters in game. I then brought in the active Lord variable and plugged it into the row name. Right-clicking the output, I split this strut to gain access to the variables for Logan. From the row found output, I set the character move var to the movement speed output. I then created a new macro and placed it after the float set. I named this new macro direction check and gave it an execution input and two float inputs named movement x and movement y. I also gave it 9 execution outputs named other, right, left, upwards, downwards, right and upwards, right and down, left and upwards, and left and down. I set the two floats to equal movement var x and movement var y before compiling and saving everything. From the other output, I led the line into a set flipbook node. I plugged in the paper flipbook component of the blueprint into its target. And from the data table node's overworld animation output, I got a get node and plugged it into the set flipbook node's new flipbook inputs. I copied this node and the two nodes going into it and pasted it 8 times, one for each of the paths coming out of the macro. I changed each of the index numbers on the get nodes to match the path they were on. In the macro, the x movement input was led into a check to see if it was equal to 0. The false output was led into a compare float that compared the movement y input to 0. The true output of the branch, as well as all the outputs of the compare float, each led into a new compare float. Move var y was set for the input of the first compare float, while all the others had move var x set for their inputs. Lining up all the outputs, they fed into the following paths for the macro output node. Right, other, left, right up, right down, up, other, down, down and up, left and down. Back in the encounter roll macro, a random integer node was fed into a less than or equal node. The random integer's node's max was set to 100. The system manager reference was brought into the macro and the E-rate integer was pulled from it and into the check. The resulting boolean was then led into the output node. Everything was compiled, saved, and closed. In the maps folder, 2 new levels were made. The first named Overworld, while the second was named Battle. Overworld was opened and a sky sphere, skylight, directional light, and player start were added to the level. From the Windows tab, the World Settings tab was opened. In the World Settings tab, the game mode was set to system_overworld map game mode, and the default pawn class was set to the map pawn. I then created a simple terrain and saved the level. Battle was then opened and given a sky sphere, skylight, and directional light. The game mode for this level was set to system_game mode test, with all other settings kept to their default states. Back in the map pawn blueprint, the current level variable default value was set to Overworld, while the zone area's name default was set to Battle. I then returned to the Overworld level. From the Windows tab, the Levels window was opened and a new folder named Battle Arena was added. The The battle level was then added into this folder with the visibility set to hidden. One last save and the system has now been completed.